So our next session is Space Technology Roundtable. So panelists, come on up and grab your seats as we change out the placards in the water. And we want to thank once again our all-day sponsors today, both Boeing and Northrop Grumman. Thank you so much for all your support. And so here they come. Here come the placards. And thank you very much also to our UAH student volunteers for helping out a lot and taking care of the things that need to be taken care of. We appreciate it. This session will be a chat between our senior technical leaders who will offer insight into their civil space, science, and security domain successes, lessons learned, future programs, funding, and long-term technology outlooks. To lead this discussion, please welcome Andy Quass, Professor and Senior Technical Fellow at Northrop Grumman. Andy.
Thanks, Jim. Just to get me out of the way, real quick, a little bit about myself. This summer, I celebrated my 45th year with Northrop Grumman. Legacy TRW, the guys that made the Pioneer spacecraft, about the time I was born. So I actually had the pleasure early in my career to have some activities with Pioneer. Small sat, by the way. Since that time, I've worked on, I think last count is 54 different satellites. My first real one with TRW was the Gamma Ray Observatory. A lot of people won't know that, but you can look it up online. Interesting mission back in 1981, 82. Since that time, worked a lot of stuff with Geostar, Leostar, ESPASats, ESPAStar, various other satellites that we're doing, including this thing that's not a small sat called the James Webb Space Telescope that I had the pleasure of participating on in the about the time of this first question, mid-2015 timeframe. And now the Jetson program, consistent with the last topic, Northrop working with Westinghouse on a solution for the Jetson nuclear spacecraft, which is very interesting. I also lead the company for all additive manufacturing for the space sector, and I'm have an academic title with the University of New Mexico as a space researcher for the university, so I have that role as well. But it's not about me, it's about this panel, and I want to tell you this is such a distinguished panel. When I agreed to do this with Lauren, and thank you, Lauren, for all the help putting this group together, I said I just don't want subject matter experts, I really want the best of the best, and so we kind of had to reach out and make sure we brought in a panel that was really tops in their class and experts, beyond experts in this, and leaders in their own respective fields. And one thing you should notice is, although their backgrounds cover a variety of different places, right now we cover civil space with NASA, we cover academia with University of Texas El Paso leadership role, and Stacy in the DoD military realm. So I think we have it covered much more than is what is typical when you think of space. We're trying to have this, and you're going to see that in the questions that I'm going to ask. They're a little bit of a cornucopia. I wanted to make sure we hit a variety of different topics and things that are interesting to all of us. And so I think you're going to enjoy this. In order of time, we dispensed with any charts. We're just going to jump right into some questions and make sure that we cover everything that we possibly can. So along that line, AC, I'll start with you to give a little quick description of who you are and why you are and where you came from.
So I think for the students in the audience, kind of proud graduate of the Georgia Institute of Technology in Atlanta, so go Yellow Jackets. Worked at a research lab there in the year 2000. My professor started his own space company called SpaceWorks Enterprises, and so I joined that as the opening of, as we will get to, the third wave of space exploration with commercial space. So that included a lot of advanced concepts, getting concepts from the back of an envelope to PDR, CDR, working with Space Force, DARPA, companies in Japan, South Korea, doing collaborations with NASA, Then in 2012, joined Virgin Galactic and what became Virgin Orbit in the Launcher One program, just trying to simply put a 55,000-pound two-stage pump-fed liquid rocket in the left wing of the 747 to launch small satellites. It's just that. So we did that for 5 years and worked with Steve Osakowicz, who many of you know at Aerospace Corporation. He left to go run aerospace. I then left to join an emerging lunar lander program at Blue Origin. So in 2017, joined Blue, and it was me and 2 engineers that helped kick off a whole entire journey on a cargo and crewed lander program and technology collaborations. Then went to a company called Reliable Robotics in Silicon Valley to look at automating all the world's cargo aircraft to fly themselves using supervised autonomy, and then applied for this job at NASA. And I think for me, it was coming from the commercial space experience is to leverage those ideas, public-private partnership, vision, projects, experience within the agency at a strategic level at NASA headquarters, where I find myself supporting our senior leaders, including Pam Melroy and Jim Free and others, of how we can do things more innovatively, taking some of those lessons learned, kind of giving those lessons back to the agency that I collaborated with in my professional career prior to coming to the agency, and accelerating these technology innovations, highlighting problems and issues, and then trying to find cross-directorate, multi-center solutions to those at the agency. And then finally, I wouldn't have taken this job if not for senior leadership. I've been to the students out there, I think when you look at a company or organization, do you believe in the mission? Do you believe that you'll grow over the next few years personally? And do you have professional mentors that you respect, value, and can take you to the next level? And so I've been very fortunate in all these organizations to have those kinds of individuals. And for me, the final icing on the cake for taking this job was our senior leadership, including Pam Melroy. I don't know if Pam was not at the agency, I don't know if I would have taken this job in terms of the vision, leadership, both publicly and even privately in meetings that I've seen. And so that all those things I think go into kind of the portfolio now at the agency of trying to help us think innovatively in different ways.
All right, good morning, everyone. It's very nice to be here. I lived here for 12 years, earned my PhD right here at UAH, yay, and University of Alabama. So it's really good to be back in Huntsville. I am Sherry Welsh, and I just retired this past May from Department of Defense after 37 and a half years. I feel like a 5-year-old and a half years. So clearly I started when I was 5. So I'm really going to need you to caffeinate. That was really funny. Come on. So I had the great opportunity throughout my career. I moved all around the country. So also to students out there, be open to opportunities. I had a plan for my career. I was very driven. It did not happen in any manner the way I planned, and that was a beautiful thing. So have a plan, but keep your eyes open for opportunities. Because of that, I was able to move all the way around the country. I worked for Missile Defense Agency right here in Huntsville, also in New Mexico. And I also worked for the Air Force and Space Force. I was also, had great opportunities, and not a lot of folks in DoD get to do this, but had a lot of opportunities to work many, many different technology areas. So I started out in aircraft structures, materials, science, and went to directed energy, lasers, high power electromagnetics. Then I went to the Missile Defense Agency, learned all about missiles, led a directorate here, and I told my boss who moved me from New Mexico, I said, I don't know anything about missiles. And he's like, you'll learn, you'll be fine. I'm like, I'm going to be leading the whole directorate on target requirements. You'll learn it, don't worry. And of course, lots and lots of hours later, I learned it, and had the opportunity at Missile Defense Agency also to get into a PhD program, which is why I ended up here earning my PhD, which was fabulous. I love this university. And I even taught here at night for about 5 years because they needed the help. Yeah, I was thank you. When asked to teach, I said, ooh, no, I am not one of those people. I don't have the patience. I don't think I'd be good at it. And they're like, we really need your help. We're like down a few people, and So I love the college, I love the department, and so I said, yeah, I'll help out. And I didn't stop until like 5 years later. So that was a wonderful experience. So I got into hypersonics, satellites, science and technology. After I earned my PhD, it opened up an enormous amount of doors for me. And so I ended up being the Missile Defense Agency Science and Technology Director. So I was into all kinds of technologies, which was a lot of fun, a lot of them space-related. So, and then I had the opportunity to finish off my last 4 years of my career at the Air Force Research Lab, where I was the director of the Air Force Office of Scientific Research, which is the basic research arm of the Air Force and Space Force. And then my last year, I was moved, because help was needed, back to New Mexico and led the Directed Energy Directorate. I retired, and an opportunity came up at UTEP, the University of Texas at El Paso, and I am now the executive director of the Aerospace Center out there, which is very fitting since most of my 37 years was spent in aerospace. So just very excited to be here, and thank you again, Andy, for asking me to be on the panel.
Good morning, everybody. Thank you. So my role as the Chief Science Officer, I'm the Senior Advisor to the United States Space Force, and I represent the Space Force interests in national security space on S&T councils, on boards, on interagency working groups, and I work on developing high-level policy for space, working on monitoring the S&T, where our investments are, and also communicating what our needs are at forums like this with academia and with industry. I have a breadth of experience in basic research, applied research, advanced demonstration, and prototyping, and I've been really fortunate in my career that I've always had access to operators, the end users, which in my personal opinion is one of the most important things. That's the first place that you start, to understand what are the true mission needs, and then connecting that with emergent S&T. And so I've worked at the Air Force Office of Scientific Research, managing the space portfolio. Before I took this position, I was the space science architect, directing the strategic investment portfolio for the Department of the Air Force in space. I also worked at the Air Force Research Laboratory, where I was transitioned several space domain awareness capabilities, including the only 24-hour imaging capability at the Maui telescope site. I later became the technical director there. And I also was fortunate to be able to work at DARPA on building some satellites, and also in some ISR, which I was also able to transition those as well. And I'm really excited to be here. I was talking to some of the students. We are so lucky that we are lifelong learners, and we get to come to things like this and talk to creative people, and constantly expanding our knowledge base. So I'm grateful to all the people that I've met today, and I look forward to this discussion.
Well, certainly the qualifications are here with the three panelists. AC, I'm going to start with you. So it's been said that the beginning of the third space age happened around 2015, plus or minus a year or so, when space companies like Northrop began to develop new capabilities, and industry partners from commercial, civil, and national security sectors converged with our government partners to develop new systems. A good example is our space logistics vehicles were really starting at that time frame. James Webb was in the final assembly of completion at Space Park. So, I mean, that was very important for us. So there really does seem to be a third space age. Can you talk a little bit about that, and what out of that you consider the biggest technology advancement, if you had to pick one?
I'd say I'd probably go back in terms of the third space age to a few years earlier, because I was part of the space age, or several of us were, in terms of the commercial public-private partnerships that have accelerated that we've seen in the last kind of 20 years. So I've been noodling on this question for the last like half day, and I think the answer, it's a complicated answer, and probably my answer to the question would be of one technology, it would probably be high rate production And it's the sense I get as you go talk to companies and government labs and the such, that, and I saw it personally in several companies I was at, that this idea of rate activity in the solar system, I think, will be very interesting. And that rate of activity is dependent upon high-scale production of large numbers of units. And so, for instance, in companies I was at, we were trying to manufacture and develop brand new liquid rocket engines, and multiple companies over the last decade and a half have put tremendous investment in additive manufacturing, high rate production. I visited, several of our large commercial space companies and others, and they're developing dozens of engines per month. You go to Redmond, Washington, and they're, Project Kuiper and Starlink are within a short drive of each other. And that will be the home of thousands of satellites produced by the planet every year. And the way they're thinking about producing large numbers of liquid rocket engines, large numbers of spacecraft that enable high rate of activity, and that is then surrounded by the concept of reusability. And so reusability for me in high rate production and high rate of activity of liquid rocket engines, launch rates, I think is game changing as we see of how we're leveraging it, how they're building on those capabilities to build things like Starship, New Glenn, other capabilities, and then leveraging that to build, as we will get to later, more even interesting architectures in cislunar space that will enable opening up the rest of the solar system. So I think high rate production, reusability of liquid rocket, and including liquid rocket engines, I think has been game changing for Earth launch, but then also beyond, I think.
Yeah, good answer. Sherry, what's your new toaster look like?
My new toaster has a UTEP sticker on it.
New mouse trap, whatever.
Has a UTEP sticker on it. And UAH sticker on it as well. As far as I thought about this, even though it's AC's question. The biggest tech advancement, all the technological advancement that has given us access, right? And as you said, AC, it's a convoluted answer because there's so much. There's been such a huge explosion, right, in space. And, some of the elements of this new age, which was part of the question, there's the obvious, right, commercialization, the public-private partnerships, and all the technological advancements that AC just discussed, the access. The sustainability and ethics, though, I think is also one piece that an element that we need to pay attention to. I'm not sure that because of all the excitement over the technological advancement, I'm not sure we focus enough on the sustainability and the ethics behind it. Space debris is a good example. And if you want to know more about space debris, follow one of our buddies, Dr. Morba Jah, J-A-H. He's a very accomplished professor at UT Austin, space environmentalist. He's a huge influencer, trying to get the word out on space debris, and I couldn't agree more. And then as far as, do we still have gaps? Yes, as Stacy and I are friends and colleagues and work together at AFOSR. We were talking not too long ago, and I said, tell me more about some of your needs. And one of the things that she mentioned is that I see as a gap that needs to be filled is, and everybody knows this, we want and we need to go deeper into space. That came from you during our conversation. And then, of course, advanced propulsion, as we heard in the panel this morning, along with space debris, as I mentioned before. So,
Very good.
Yeah.
Stacy, I'm sure you got some good ones, too.
So yes, the Space Force, we have a saying, leverage what you can and build what you must. And I would say that the commercial industry is giving us a lot of opportunities to leverage what we can. Space Force, commercial industry is pushing launch. Space Force is buying space domain awareness data. We're looking at, commercial communication, so lots and lots of opportunities. I think it's interesting that the new space age started in 2015 because 2015 was the year that the federal share of basic research dropped below 50% for the first time since World War II, which I think is a little bit scary. And that is because the commercial advances are really built on the foundation of federal government investment in S&T. Like a lot of the launch engines came out of research funded by the federal government. The ESPA ring from Northrop Grumman was funded initially at the Air Force Research Laboratory, and also just kind of the whole small satellites. They made fun of us in the S&T community when we started with those, and hey, guess what? They're here to stay. So I would say that we need to make sure that while yes, commercial is wonderful, commercial is providing lots of stuff for us, but hey, they're providing the innovation for us, they're providing the discoveries for tomorrow. And if we don't have a balance of both, our capabilities will soon become stagnant, and we'll be leveraging those from other countries that are investing more in S&T.
Good, thank you. Great answer. So Sherry, artificial intelligence and machine learning is on almost everybody's chart these days. We've been doing it for 20, 30 years, but it's become really now a point of operational applications and things. So a good friend of mine, Dr. Andy Williams, who's the Deputy TEO for AFRL, briefed at the Professional Aerospace Contractors Association meeting in Albuquerque a few weeks ago. And he defined a set of wormholes, and AI/ML was one of them, where technology advancements for space had to really speed up and get going, because they're things that we need so badly that we're kind of lost without it now that we know what it can do. So a question to you guys is, do you agree, and Sherry, you can start, and does the DoD, academia, and NASA have budgets to support influencing all our products with the AI/ML?
So I do agree with Andy. He was a great colleague of mine as well at AFRL. So I do agree with Andy. He has great insight, as you know, and great vision for space with respect to AFRL and science and technology. So I do agree. With respect to the budgets, I can't really speak to that part anymore, but I think the bigger question is culture. I think we have to really keep focused on the culture that we need to shape to get people more comfortable with AI. I assume in a forum like this, everyone in this room, and I know myself, I'm the same, I use AI every day. Every day. I'm actually, for my work life at UTEP, for my personal work, I own a grocery store in New Mexico. For that, I've used AI, and for my personal, I use AI. So I'm using AI nearly every day for lots of different reasons. Not to do my work for me, but to enhance and make my work more efficient, right? Gather my thoughts together more quickly, be able to assess something a little more quickly. So I think there are so many concerns over AI, and they're very valid concerns. But you still have, I think, a large population of people out there who are very scared of AI. And so some of the things they worry about are not things that they really do need to worry about. And it's mainly because they're not using it, right? So I think using it is the key, because I think culture is the biggest problem. You could throw as much money at it as you want, right? It was the same with digital transformation, right? You've got to have the right people in the right spots to be, as people in this room are, we're all very forward-leaning people, very unconventional thinkers, very non-traditional thinkers, which tends to make us more innovative. We do things differently than everybody else. For any students that might be left in here, let people just look at you strangely if you try to do things differently. I got used to that look my entire career, and everything turned out okay. So, digital transformation is another good example. So at AFRL, we struggled with digital transformation. We made strides, but we were struggling, right? And then Google laid off a bunch of people. Our commander at the time, Dr. Heather Pringle, brilliant woman, now the Space Foundation CEO, she hired Miss Alexis Bonnell from Google, and she has changed things in AFRL so rapidly, so quickly. As I think as she said one day, she goes, I feel like I'm queen of the nerds. And she was having so much fun, but we had a lot of digital transformation. We had made progress, don't get me wrong, but we were trying to double down on some of the executives' time to lead digital transformation. So that's two executive level positions at the same time. Probably not the best way to go at it, but we were just trying to get moving, right? So I think it's more so with the culture and having the right people in the right places. I know I took that with me, and my comfortable, nature with AI and at UTEP, it's a nice little plug, I have to do it, but I'm creating a new division in the Aerospace Center, and it is space technologies and AI-driven research and advanced materials, specifically for what you're talking about. We've got to get to the scientific breakthroughs faster, and I totally agree with Stacy. I don't feel like DoD has got the right balance of funding that is going to, I think basic research is taking cuts this year and next year in basic research, and I don't know about you, we all realize it, but I don't think the general population realizes our #1 world leader seat is not guaranteed. It's not guaranteed. And China is no longer just nipping at our heels and standing on our front porch. They're sitting right next to us at the table. And so there needs to be a sense of urgency with funding and activities.
That's a good answer. Let me switch a little bit, but I want to stay on that university focus a little bit. So a question for you, Stacy. You've had a major influence. I've seen it over the years in several programs where AFOSR and AFRL work together on research projects with an academia focus, right? And the one in particular, and many of which Northrop participates in, and one in particular that's worked very effectively for us and industry in general is the Space University Research Initiative called SURI, which was awarded to Carnegie Mellon, a team from Carnegie Mellon led a few years ago. And they're in their 3rd year, and we talk to them almost daily about what they're doing and have regular weekly calls on ways to influence a lot of the work we're doing in space logistics. Another one that came out shortly after is the various Space Strategic Technology Institutes, and those are bigger dollars, $35, $50 million. And now a team led by TAMU on space mobility, another one, University of Cincinnati on space mobility, and recently an award to the University of Michigan on power and propulsion is kicking off next month. These are really well thought out efforts. I look at them and say, gosh, somebody really put a lot of effort into this, and I got a feeling you were a key part of that. Are plans for these kind of things going to continue at universities to try to get them more involved with the real world problems?
Yes, definitely. And I'll say that when Space Force first stood up, our senior leaders actually went to the universities immediately to start building partnerships because we understand that our next discoveries, our next capabilities are going to grow out of research done at universities. That's where Tech Surprise is birthed, and that's where we get wise to that. So those are really important. Now, the Space Force has a program called the University Consortium, and underneath that umbrella is our activities with academia. And one of them is the Space University Research Initiative, or the SURI. And we actually have about 7 of those that have been awarded. And SURI is a combination of 6.1 and 6.2, also with encouragement from industry, which is important, as well as connecting it to the end users, to the operators. And we set that up. The Maui Space Surveillance Complex, I was fortunate to be there. And I saw one of my projects, I had basic research funding from AFOSR, I had 6.2 and 6.3 funding. Doing all of that together with the operators enabled us to actually develop a capability that when I first briefed that at a conference, so many people came up to me and said, oh, that's impossible. You're never going to do that. Why are you wasting your time on that? And then in 4 years, we were actually delivering images to the operators. And so I just see it as a wonderful partnership, kind of like people talked about the golden triad, I think, yesterday. Bringing academia, industry, and government together is wonderful. Now, the first 2 stories were in on-orbit servicing and logistics, and in space domain awareness. And in just 2 years of those starting, the Carnegie Mellon effort, they're already delivering control and dynamics algorithms to Space Systems Command that are going to be used in an upcoming demonstration, which is pretty unprecedented. And the SDA First Surrey is led by SUNY Buffalo, and they are actually working with AFRL to transition algorithms to SSC as well as to the 19th Space Defense Squadron. You mentioned our SSTIs. We have quite a few of those as well. Those are also already delivering. The first SSTI was in space domain awareness. They're working with the Space Systems Command SDA TAP Lab, which is a wonderful opportunity for commercial industry and academia to be able to participate in sprints on specific defined Space Force problems that also have associated data, so you can work on testing your algorithms with that real data, wargaming those with a team, and then the idea is to rapidly transition that into this Space Force. Coming to events like this, I talk to folks to get new ideas because we're always looking to improve. And one of the things that Space Force is doing is we're standing up Space Futures Command. And Space Futures Command puts under one field command our Space Warfighting Analysis Center, Wargaming, and what's called the Concepts and Technology, which will have foresighting, environmental, predicting the future operating concepts, and the future operating environment. And the idea for the output for that, the goal is to have the objective force. And we see lots of opportunities where industry and academia can work with us throughout that process.
Thank you very much. AC, so again, moving around the space world, I spend a fair amount of time on the various LISIC calls every month, and I think it's a great effort to get the community together to discuss lunar exploration goals. DARPA, unrelated, did their Luna 10 program last year to develop lunar infrastructure concepts. We participated in that and developed a very effective lunar rail system, which was one of the 14 that were chosen, and we've outbriefed and it's gotten rave reviews. What's NASA's current approach to establishing a human presence long-term on the lunar surface? Big question. You could take hours answering.
Right.
Give me the 2-minute answer
Yeah.
of where the vision is of where that's going.
So I think it's been pretty cool to come to the agency, and the agency has provided me kind of a systems engineering decomposition approach for this exact question. And some of that is informed by elements that were existing prior to recent NASA leadership coming in. But I think Pam and others deliberately set out on this course to document and write down this process. And so it starts with this idea of a blueprint for exploration of the solar system. You start from that idea. You decompose that to why we're doing that, and we decompose that into 3 whys of science, national posture, inspiration. You then decompose that further into 63 objectives. And we've all written this out, and you can download the document from the blueprint vision to the 3 whys to the 63 objectives, and then decompose that even further into architecture segments, as we call it, kind of timelines of exploration, and what elements and technologies that we would have. So the first segment in this decomposed kind of strategy is the human lunar return segment. That's the first few Artemis missions, Artemis 1, Artemis 2, Artemis 3, et cetera, to develop the initial capabilities for a 6.5-day surface stay, to develop a lunar space station we call the Gateway, and then we build upon that to what we call foundational exploration, the next segment, where we expand capabilities, expand the Gateway, add long-distance lunar surface mobility, and invest in new technologies. And then we'd get to sustained lunar evolution, SLE, which is where you have even longer stays on the surface, more capabilities, even more public-private partnerships, and that all develops technologies, capabilities, experience to then attempt the first human Mars mission, and then later missions in the solar system as well. So that that process has all been documented, and we've been very public. And also, it's been very cool to see that the agency has also been public in terms of what we call the strategy document that helps kind of inform that. It's called the Architecture Definition Document, the ADD, and we have an annual process to publish that and to have workshops with internationals, commercial industry, other government agencies to get feedback on that. So that's been a very transparent process that I'm very happy with. And then our Space Technology Mission Directorate, it's also been very public in listing an inventory of technology shortfalls. So over the last year, they've gone through a process where we've published their shortfalls, asked for stakeholder input, including all of your input, and then documented the results of that. I think that that's a signal to technology challenges and an initial list of some of the top technology challenges. And you take those technology challenges with these architecture segments, and then you can see where these technology challenges can get us to make human lunar return even better, foundational exploration even better, and get to the sustained lunar evolution piece. And what we use the term sustained lunar evolution for that segment of our architecture, and I actually have a simpler word for that. It's called the lunar moment. And what I mean by that is there's a moment in this century where a human walks on the moon, and from then on, there will always be a human on the moon, right? And we make the point at NASA saying that there's an International Space Station, and some of you students in the audience have been alive when there's always been a space station up there with a human, and that's been pretty remarkable. But there are children yet to be born in this century that will know a moon that was always inhabited by a human. But what are the technologies, capabilities, communications, power technologies, life support technologies that are needed to enable that lunar moment, which is reflected in our sustained lunar evolution segment of our architecture definition document. So I think we've got a plan, we've got a strategy. Our Space Technology Mission Directorate has even a set of technology investments and has done a first cut at the prioritized list of that. So I think that's been really cool to have, that's public for all of you to see of how we're thinking about this question that you've posed about what is our exploration campaign.
Great. That's a very concise answer that I was looking for. So thank you very much. I don't want to lose sight of the AFOSR. I think a lot of people don't really understand what their role is in this world. So I'm going to throw it to you two that just says, I know that they develop and transition high risk, but also big payoff technologies for the Air Force programs. It's clear the insertion, I've seen it over the years very effectively. But behind the scenes, what's your process for determining, which programs get funded, and how do you measure success as you introduce the technology that you're working on?
Yeah, go ahead. Oh, you want me to start? Sure. I was the director of AFOSR, and Dr. Williams and I worked together there. We hire. So let me say first, though, that we always stay in a high-risk posture in basic research throughout our entire ecosystem, right? Government, industry, academia. The place where it's the easiest to take the risk is in basic research. The place that you get the biggest benefit from taking that risk is basic research and scientific breakthroughs. When I'm always talking to folks about this, I always remind them that you can have people who are wickedly smart and think of all the coolest tech that they can imagine, but if the scientific breakthroughs haven't happened in the universities, in the labs, it's not going anywhere, right? So at AFOSR, we spend a lot of time being very careful about the program officers that we hire. Those are the people who are going out to the universities. They're receiving the information from the universities, proposals and white papers. They're very accomplished scientists and engineers in their own right. So we're very, very particular about the people that we hire to lead that in AFOSR. They are people who are willing to take risk. And there's one program officer specifically that I remember when I first got to AFOSR, and I said, I was trying to understand, how do you do your job? How do you pick? And he said, well, I'll give you a good example. He said, I had a researcher from a university come to me and say, I got 3 ideas here, but I don't know which one you're going to be interested in funding. And so the program officer, I think it was Dr. Fred Levy, I think, and he said, well, which one keeps you up at night and has the biggest payoff, but is not as likely to be, And he said, number 3, and Fred was like, number 3, that's the one I want to fund. The high risk, high payoff. So that's how we do that. And as far as like measures of success, a lot of DoD leadership doesn't necessarily understand basic research, and I get that. If you haven't worked basic research, you don't really understand it fundamentally. So I had a leader one time ask me, well, we need you to come up with your transition rates, transition being from basic to applied. They were going to use the transition rate as the measure of success of AFOSR. And I said, you can do that as long as you understand that my numbers should be very low. If not, you should fire me, right? There should not be 90% transition rate. What does that mean? That means I'm taking very, very low risk. If it's around 50%, I'm probably taking low to medium risk. The transition rate needs to be low. So trying to help them understand that that is not the best measure. The best measure is look around. Look around you. Everything started from basic research. So this is an age-old problem, right, of how do you measure the success of basic research? And a lot of folks will say it's anecdotal. Other folks, say it's anecdotal, and you can also, provide data. But what data? That's where we can't come to fruition on deciding what data really identifies whether basic research is successful or not. I tend to go anecdotal, although I'm a data person, so I'm always trying to figure that out, but that's a hard one. Go ahead,
Stacy, I'm sure you got some adds to that.
Yeah, so all of the military departments have a basic research office, and AFOSR is the Department of the Air Force's basic research office. National Science Foundation also has a goal and mission to fund things of national security, and both of them have their place. I think what sets off places like AFOSR, the Office of Naval Research, and the Army Research Office is that at NSF, scientists pick the science that they fund, which is really important. But then at AFOSR and the other ones, Department of Defense employees pick what we fund. And that's really important because those employees are really well connected with the needs of the service, and they're kind of like matchmakers. They're, as Sherry said, matching that high risk, high reward to that. And AFOSR has about 55 portfolios and areas that are really important to us. We talked about artificial intelligence. Artificial intelligence does really well when you've got large data sets, you have well-defined rules. But if we were to do a war in space, I'm not going to compare that to a self-driving car. I would compare that more to a car in a demolition derby, and there's lots of challenges still for that. And so AFOSR looks at machine intelligence, understanding how the brain works. How can I apply that to artificial intelligence to make smarter machines? The Space Force, we anticipate in the future that we may have robots in space doing servicing like we chatted about. How do we trust those machines, particularly when they're working in space and the operators are here on the ground? So there's lots of things that we really need to invest in from a basic research perspective to buy down some of these challenges that we have now from a capabilities perspective. And just really quickly, in the original question you asked about how do we measure our success, every nickel that we put into universities goes to produce our future workforce. So there is 100% effectiveness in that. But I will say Colonel Russell, our international research director, wanted to look at how is the effectiveness of AFOSR's international effort, because AFOSR invests not only in the best science in the U.S., but the best science in the world. And he found that AFOSR-funded research actually was 30% more impactful when you do a dimension study to look at the research impact. And I think a lot of that has to do with just the fact that the program officers really do a good job of going to conferences, meeting with scientists, and identifying really some of the best research.
Great. Thank you very much. That's a great answer. And I have noticed, as the years gone by, my 45 years, how the students coming out are much more prepared to butt in seat doing some really quality work versus just being a technology capability. So kudos to the government for making that happen. Okay, I want to get a little specific in the few minutes we have on some technologies and specifically that I'd like to address. And one that's close to my heart is the in-space assembly and manufacturing and the space servicing that goes along with that. So can somebody address the fact that a little less than 2 years ago, the U.S. Government Office of Science and Technology Policy defined a new national strategy to develop ISAM capabilities and show a commitment to the scientific development and innovation that occurs and using a diverse U.S. skilled workforce and international as well to solve this problem or this opportunity. Things like COSMIC and CONFERS popped into the system, and we're all actively involved with that, aggressively working the technology and the standards. And Northrop Grumman in particular, I had to get a plug in, has invested heavily into ISAM, and to date is the only company to actually perform an in-space servicing operation, and we've actually done it twice. And between the two, we've gotten 8 years combined of satellite servicing, putting a Intelsat in the right place after they were basically done, with their missions. So these capabilities have essentially demonstrated that the space domain has the option to include an operational and support tail that is great for your car and everything on Earth, but we've never had in space before. That we don't just put a satellite up and forget it. We now have the opportunity to go up in the future and do things to it, whether it's an upgrade or a repair or whatever the case might be. And I think NASA and DARPA have been very good in transformation of that into this new domain. But my question to you is, do you see a place for the rest of the DoD and NASA and academia to be part of space servicing and being able to modify future satellites? You see a role there? Anybody?
So AFOSR and the Space Force University Consortium, we are investing in enabling technologies for on-orbit servicing and logistics. We have not done an assessment in terms of a business case, what makes sense. Nowadays technology just moves so quickly that tech refresh might be more important than actually servicing a system. It depends on what the scenario is. It may be, I've got a satellite, it has a minor flaw, it's already been up there, it's already been tested, it's already been working, I want to keep it up there. So then I may go and fix that, or I may refuel. So I would say the jury is still out on that. I think we are definitely, I see a business case for that in the future for the Space Force, but I don't know, just as technology changes, there's always a lot of unknowns.
Yeah, some of them are fairly simple, like just being able to go up and dislodge a solar panel that's not seated properly. I mean, there are some easy things to do. We're not doing them yet, but they're really on the drawing board, and we're working a lot of the details. Anybody else want to comment on that?
Oh, just quickly, and then AC, over to you. Just from the academic perspective, we heard the national strategy from OSTP loud and clear, already doing work in that area. Actually, we just put in a proposal for like microgravity manufacturing even. So from the academic perspective, we've heard that loud and clear, already working in that area.
Yes, I think in our Space Technology Mission Director, we've had several investments. We've got technologies we've invested in the OSAM-1 program that I think we're now looking at how to provide that to industry and others, of how to take that investment we've done in that program and leverage the tech advancements in hardware and software. And so I think there are initiatives to kind of ask people what they could do with that kind of knowledge. There are other parts of the agency that have invested in kind of small-scale technology demos with commercial industry in some of those technologies. And then kind of another version of that, separate from STMDs, I think about the in-space kind of assembly, refueling, kind of demonstrations and capabilities we're going to have from our human landing system providers, both SpaceX and Blue Origin. Maybe that gets to a later question that you might have, but it's like separate from the STMD investments, some of what we're doing of how in the Artemis program in terms of rendezvous, prox ops, large propellant transfer, refueling, cryogenic fluid management, that's like to me another version of like in-space assembly that sometimes doesn't get as much play, but it's also about how to connect assets in space, how to transfer large propellants, the sensor technologies required to have large assets rendezvous with each other in low Earth orbit, NRHO, and that's like, I think, another version of this whole ISAM kind of mindset that we're going to see, including now as part of Artemis. So,
Yeah, great, good answer, thank you. I want to pick up a little bit of the military side of this as well. So, Stacy and Sherry, can you talk a little bit about the threat to advanced space? I mean, we putting up high-valued assets. Those assets are getting even more complex and more capable. I see, you both have been active participants in developing space strategy. So the backbone of that strategy has to be, I need to protect those assets. And so you think the DoD is sufficiently addressing the threat? And are our future assets in space always going to be at risk?
So, so there's lots of risks. There's natural risks, there's the space weather environment, there's debris that Sherry mentioned earlier, and then there are also threats from countries that want to deny our access to space. And space will always be under threat because of the nature. We don't have some rear echelon where we can retreat to. We don't have space garages and depots and stuff like that. So we're constantly exposed. And both China and Russia have developed and fielded counter space capabilities that are designed to hold U.S. satellites at risk, no matter what they say in international fora. China's developing systems to kill our satellites, but they're also developing space capabilities so that they can better track, target, and strike our joint forces. Russia continues to violate international norms and treaties and proves itself to be an irresponsible actor across the board, including space. And the threats are only getting larger. So we definitely have to plan for that, and the Space Force does. I think a good first line of defense is deterrence. If you make it such that attacking the satellite doesn't get you what you need is always the best way to go. We're also looking to accelerate and transition more resilient architectures, and also developing better space domain awareness capability so that we can detect and attribute those threats. Because there's a quote by General Thompson, who used to be the Vice Commander of Space Operations, where he said, every day one of our satellites is attacked with reversible attacks, with directed energy, cyber, electronic warfare. And so it's definitely a high priority and definitely an area of concern, and an area that we're working on.
Yeah, and we should never get to a point where we feel like we're doing enough, right? So as far as, is what DoD is doing enough, I feel like I can speak in general, being a DoD employee for the 37 and a half years, that, we don't ever feel like we're doing enough. There's always an evolution. We're always evolving and working on things. Space assets will always be at risk, right? We all know that. Because our adversaries' capabilities are increasing just like ours, their technological capabilities. They're doing just as much as we are, and they're advancing just as fast as we are in a lot of cases, and sometimes a little more. So there will always be risk, as Stacy mentioned, but as far as DoD's response, the stand up of Space Force is one, right? Just the standing up of Space Force is one great response. Updating policies, right? They're currently working on those now. And then from the tech and operational community, just building resilient systems to the best of our ability. And as Stacy mentioned, deterrence, right?
Okay, good, thank you. AC, I want to get you a question on a fun subject of Uranus and Neptune. We haven't been there since the Voyager years. I was a young man when that happened, so at least when we launched that. So now that I'm an old man, are we ever going to go back? Do we have any, is there a NASA goal for outer planet exploration?
Right, so within our Science Mission Directorate, they set their priorities through a decadal process of having the best minds in the nation think about the top science goals and objectives and the concepts that could meet that. So several years ago, the latest Planetary Science Decadal Survey listed Uranus orbiter and probe mission as one of the highest priorities, and so that is now some of the core technologies people are looking at of what are needed, the concepts that are needed for such a Uranus orbiter and probe mission. And I think that is high in the minds of a Science Mission Director as maybe the next flagship potentially for them in terms of planetary science. Why do you want to go to such a target? Well, there are how the planet of Uranus was formed is very interesting. Its current tilt, the atmospheric composition, and how this gas giant has formed. It has 5 major moons that might be icy worlds, similar to Enceladus and Europa. That's a very interesting kind of investigation. And also, Uranus can also provide us information on how exoplanets are formed. So as you know, we've had observatories that have found direct and indirect evidence of exoplanets, and Uranus can help us in that investigation too. So all these science reasons have resulted in mission concepts that different folks have put together that include an orbiter that would go to the planet for a several-year mission, as well as investigate some of the icy moons, and then possibly send a probe out as well. So it's high on the minds of our Science Mission Directorate as the next flagship for a Planetary Science Decadal Survey, most likely in the 2030s in terms of when that mission could potentially be put together. And then there are different parts of the agency and others that we work with looking at what are the science questions and some of the technologies we need for such a 2030s kind of mission. So it is very high in the minds of SMD, very high in the minds in terms of outer planet flagship kind of missions that hit the decadal survey question. So yeah, it's like come back around after 40 years as an interesting target that we never fully explored. And actually from the icy moons objectives to the formation of gas giant planets to now how exoplanets form. These are questions that we hadn't really thought of even 40 years ago of why to go to this body, but now they've emerged, and so yeah.
Great, thank you. Jim, where are you? Are we out of time?
Lauren is
She's the master?
yes.
We could probably handle a question, maybe? I got a sheet
No, we
load
have
of
time
questions.
for one question, because we're already a teeny bit over, but
Well,
we
we
can
started
make
late.
time.
We started
Yep.
late. Didn't we? Yeah. See, the man says we started late. We got an extra 10 minutes, right? Yeah, we're good. If not, I got some really good questions. I'm going to keep going then. I like this one because a lot of particularly the students work in hosted payloads. Hosted payloads, I think, really came into fruition because of the fact that it was too expensive to get there on your own, right? It was too expensive for the launch. So now that we've really, I won't say completely solved the low-cost access to space problem, but still, it's an opportunity to get there. Are hosted payloads going to start falling off a little bit, or are we not going to have being able to get a ride to space needed, or are we?
Academia hopes not. We hope hosted payloads, obviously, it's good for us to,
Yeah.
put our experimental payloads on there.
Yeah, I agree.
Yeah, and I think we have an active program that all of you may know about if you go to the SmallSat conference in Utah every year of a University Nanosatellite program to provide opportunities for those that want to put in proposals for their payloads for both suborbital and orbital rides. And so I think we recently, over the last year, even added more vendors to these suborbital and orbital capabilities. So I think the other thing I'm excited about is not those opportunities are diminished, but we have suborbital opportunities with multiple providers now. We have orbital opportunities with this University Nanosatellite program. And then we've been working with industry on re-entry capsules. Mm-hmm. So some NASA technologies have made their way to re-entry systems.
Our Cygnus.
And so those are also opportunities for send payloads up, do some experiments, and to bring them down. Hopefully the university, some of those vendors are now in a pool that we offer to folks. And the other thing I'm excited about is not just kind of our space science community, but our aero communities and other communities that can also leverage these capabilities.
Yep, good. Marty, you got a question?
I do. Thanks, Andy. And this has been great, so thank you very much. sometimes you can't do the technology investment and make the technological leaps before you get into the program. Sometimes the program's formed and you got to do it in parallel, you got to do it in the context of the program. Is there a certain amount of technology development that you do within any one of the programs that's the right amount, too much, too little? Or is there some practice that goes into an aggressive, outer planets mission, or a big new telescope like Habitable Worlds, or, even, figuring out how we're going to do Mars sample return or something like that? Is there a way that we can more effectively do the technology development within the context of doing the big, aggressive programs where we're really trying to move the needle?
I don't know. Yeah. The way I think about it from industry experience and others is, what are the top technology challenges? So, for any mission like an outer planets mission of some type, you've got 100 technology challenges, and you can address all of those. So there's one question of, what will the reviewers, when they score your proposal, think in terms of technology readiness? So that's one question. But I think about the top technology challenges. So what are the 4 to 5 technologies you must solve? Because if you don't solve those, then all the other 95 technology maturation activities don't really matter. And so for an industry, for instance, when I was at industry, when we were proposing, a cryogenic lunar lander, we realized, well, the liquid rocket engine is going to be a very critical part of that, and no one has developed that, so we're going to start on that right now. And then we also recognize, well, cryogenic fluid management technology is slightly immature for what we need, and we're going to get started on that now. Now, there are other technologies like landing sensors where we also did some maturation, but we also found some NASA sensors we could possibly leverage, so we kind of went that route. So I think it's like, what are the top, I think about the top few technology challenges you must solve, strategic technology challenges, and then everything, and then focus on that initially, and then the other technology challenges you'll work out as well. So that's like one rubric or calculus I think about.
And I'll just add, one of the things that I hope that we go to in the future, digital engineering has really advanced quite a bit. And I see that as a great low-risk, low-cost way to really map out what the expected system is going to be. And so I think that's going to be really powerful in the future. I will say that historically, the gigantic acquisition programs have taken so long, and the way that technology is advancing at such an accelerated rate, that building something that may already be obsolete, just scares me. And I think that we need to make sure that as we go forward, we need to be open-minded, we need to be constantly scanning the new technology, and we need to be flexible enough to make changes in our acquisition direction so that we can incorporate better technology and have a better capability at the end.
Okay, we're getting the boots, so thanks, Marty, for the question. Good answers. I know you guys all think you're getting paid for this, but you're not. I forgot to mention. So thank you very much.
Well, we had great Southern food. I mean, Alabama, every time I come here, I always eat so well. So thank you.
Yeah. Thanks, guys.
Thank you so much. This was terrific.